Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Dear students, this lecture is for grade 8, boys and girls both wings, subject chemistry. And in this lecture, we are going to start another chapter, that is chapter number 4, which is about the structure of molecules. This is my 23rd lecture, and I am your lecturer, Mrs. Saira Jamal. The major concepts of this chapter are: why do atoms react? What is chemical bond? Types of chemical bonds, intermolecular forces, and nature of bonding and properties. Coming towards the first topic, why do atoms react? Dear students, you notice that each period on the periodic table starts with alkali metals. Alkali metals like group 1A metals are called alkali metals, except first period that starts with hydrogen atom. You know that the first period of the periodic table is composed of hydrogen and helium. Hydrogen is present in group number 1A, while helium is present in group number 8A, and ends at a noble gas. Except first period, all the other period they started from alkali metals and ends by the noble gases. The noble gases have electronic configuration, valence shell electronic configuration, or the outermost shell configuration is Ns2Np6. N means any shell, maybe they are present in period number 1, 2, 3, 4, not in one. In one actually we have only Ns2, that is of helium, but for the second period, third, fourth, the n value varies. Second period, n value may be 3, so third period. If n value is 4, so fourth period. N value 5 means fifth period, and 6 plus 2, 8 electrons. It means all the elements which are present in group number 8, they have 8 electrons in their outermost shell or in their valence shell. That's why they are called noble gases, because their outermost shell is completely filled. These elements are sometimes called the inert gases. Inert, this is because they do not participate in any chemical reaction or in many chemical reactions. The reason is that outermost shell is already completely filled, so they don't need to participate in a reaction. They are already stable. The other atoms, they react together because they are unstable or their outermost shell is incomplete. So in order to complete their outermost shell and to get stability, they participate in chemical reactions. Electronic configuration of first three noble gases are shown below. The first three elements of group number 8, a helium, neon, and argon. Configuration is 1s2, and for neon is 1s2, 2s2, and 2p6 is also here. It is missing here. 1s2, 2s2, 2p6, because atomic number of neon is 10. So it has 2 electrons in the first shell and 8 electrons in the second shell. This is 2p6. Then argon is 1s2, 2s2, 2p6, 3s2, 3p6, total 18 electrons. So atomic number of argon is 18. You can see that in all these cases, the outermost shells are completely filled. The first shell can accommodate 2 electrons, so helium has 2 electrons in the first shell and it is completely filled. There is no second shell or third shell in helium because atomic number of helium is only 2. While neon is 10, so 2 electrons I told you is in the first shell, and 2s2, 2p6. P6 is here. 6 plus 2, 8 electrons are in the last shell. In this case, 6 plus 2, 8 electrons are present in the last shell. This one is 3p6. 1s2, 2s2, 2p6, 3s2, and this is 3p6. So the n value is 3. So in third shell, 6 plus 2, 8 electrons are present in third shell. Note that these elements have completely filled outermost S and P subshell. In helium, S subshell is completely filled, while in case of neon and argon, the P shells are, or the P subshells are completely filled. Helium contains 2 electrons and the remaining noble gases contain 8 electrons in their outermost shell or in their valence shells. You can see the group 8 elements: helium, neon, argon, krypton, xenon, and radon. So atomic number of helium is 2, neon is 10, and argon is 3. We discussed these 3 elements. N value for argon is 3 because it is present in the third period. Neon N value is 2, it is present in second period, and for the helium it is 1 because it is present in the first period of the periodic table. In 1916, a chemist G. N. Lewis used this fact to explain why atoms undergo chemical reaction, or why do atoms react. He called this explanation as octet rule. Octet, an octet is a set of 8. What is octet rule? The tendency of atoms to acquire 8 electronic configuration in their valence shell when bonding is called octet rule. It means that the atoms, in order to get stability or to have electronic configuration stable, same like the noble gases, they will try to have 8 electrons in their outermost shell. So the tendency of atoms to have 8 electrons in the outermost shell to get stable and to have electronic configuration same like the noble gases, this rule is called octet rule. So definition of octet rule is the tendency of atoms to acquire means to gain 8 electronic configuration, means having 8 electrons in their outermost shell or valence shell. When bonding, when they two atoms they come close to each other to form bond, then both the atom will try to have 8 electrons in their outermost shell, while because they are going to make a bond. So they will be stable only if they have 8 electrons in their outermost shell. So this rule is called octet rule. In forming compounds, atoms tend to gain electronic configuration of a noble gas configuration, because the noble gases have completely filled outermost shell. They have 8 electrons in their outermost shell. So the rest of all the atoms, they are trying to have same completely filled electronic configuration like the noble gases, and that's why noble gases are highly stable and they does not participate in bond formation. Remember that each noble gas except helium has 8 electrons in the outermost shell. Thus, the octet rule takes its name from this fact about noble gases. Next rule about the bond formation is duplet rule. Duplet comes from 2 and it is defined as the tendency of some atoms to acquire or to gain 2 electronic configuration in their valence shell when bonding is called duplet rule. The definition is same like the octet rule, except here you have to write to acquire 2 electrons, and in the octet rule you have to write acquire 8 electronic configuration in their valence shell when bonding is called duplet rule. Helium has 2 electrons in its valence shell or its outermost shell, and it is already completely filled. So it is chemically inert. Chemically inert means it will not participate in bond formation because already its outermost shell is completely filled and it is highly stable. That's why we call it inert. Some elements that are close to helium on the periodic table tend to achieve 2 electronic configuration in their valence shell. Close, close to helium means which have atomic number close to helium, like lithium has atomic number 3 and beryllium has atomic number 4 and helium 2. So 2, 3, 4 are the elements which are which have closest atomic number to the helium. So helium on the periodic table tend to achieve 2 electronic configuration in their valence shell. For example, hydrogen. Hydrogen also has atomic number 1, helium 2, lithium 3, and beryllium 4. All these elements they have closed electronic configuration or atomic number like the helium. So hydrogen has one electron in the outermost shell, and it will try to have two electrons in the outermost shell, so it will gain one more electron. Helium already has two electrons, it is filled. Lithium has two electrons in the first shell and one electron in the last one. It will lose that one electron, and then the inner shell will be the outermost shell. Same is the case for beryllium. Beryllium has two electrons in the first shell and two electrons in the outermost shell. So it will lose two electrons and will have configuration same like helium. Same like helium. You can see here atomic number of hydrogen 1, then helium 2, lithium 3, beryllium 4, and then boron 5, carbon 6, nitrogen 7, oxygen 8, 9, 10. So the periodic table is on the basis of their increasing atomic number, and atomic number is in a sequence. Example 4.1, find the number of valence electrons in the following atom using the periodic table. Dear students, as you know that all the elements which are placed in the periodic table, they are placed on the basis of their valence shell electronic configuration, or the number of electrons which are present in their outermost shell. So all the elements which are present in group number 1, they have one electron in the outermost shell. Group 2 have two electrons, 3 has 3, 4 have 4, 5 have 5, and 6 has 6, so on and so forth. So the group number actually indicate the valence electrons which are present in that atom. Carbon, magnesium, and phosphorus, we have to find out their valence electron. First one is carbon. But remember that the group number of main group element indicates the number of valence electrons in an atom. Check the group number. The group number will indicate the number of valence electrons in an atom. Check the group number of elements in the periodic table and find the number of valence electrons. First one is carbon. So carbon belongs to group 4A, so it contains 4 electrons in the valence shell. As it is present in group 4A, so definitely it will have 4 electrons in the outermost shell. Magnesium belongs to group 2A, so it has 2 electrons in the outermost shell. Phosphorus belongs to group 5A, so it has 5 electrons in the outermost shell. Then self-assessment exercise 4.1, find the number of electrons in valence shell of the following atoms using the periodic table. This self-assessment exercise is same like the example 4.1. Silicon is present in group number 4A of the periodic table, so it contains 4 electrons in the valence shell. Sulfur belongs to group 6A, so it contains 6 electrons in the valence shell. Bromine belongs to group 7A, so it contains 7 electrons in the valence shell. Argon belongs to group 8A of the periodic table, so it contains 8 electrons in the valence shell. Potassium belongs to group 1A of the periodic table, so it contains 1 electron in the valence shell. Nitrogen belongs to group 5A, so it contains 5 electrons in the valence shell. So from the position of these elements in different groups will tell us about their valence electrons. Next topic is about the chemical bond. What is chemical bond? Chemical bond means the attractive forces by means of which atoms are held together in a stable arrangement. When two atoms they combine together and then they form a bond, that bond actually is the attractive forces which held those atoms tightly together. So that type of bond is called chemical bond, the attractive forces between two atoms. To bind those two atoms together or to hold those two atoms together is called chemical bond. Chemical bonds are made by valence electron. Definitely the outermost electrons or the electrons which are present in the outermost shell, they participate in bond formation and then the two atoms combine together. Atoms combine with one another by losing, gaining, or sharing electrons in order to attain stability or to attain the nearest noble gas electronic configuration. All the atoms they are trying to have stable configuration like group 8 elements. How the atom will gain stability? The atom will gain stability by losing, either they will lose electrons and will form cation, or they will gain electron or will form anion, or they will share electron. So these are the three ways by which the atoms can get stability or can get complete outermost electronic configuration, same like the noble gases. Chemical bonds are of four types depending on the tendency of atoms to gain, lose, or share electrons. There are four types of chemical bonds. Those four types are ionic bond. Ionic bond is formed between metals and non-metals. Means metals and non-metals react together and then they will form ionic bond. Metal, suppose sodium is a metal, chlorine is non-metal, so sodium and chlorine will react together, will form sodium chloride. So sodium chloride, in sodium chloride the bond is ionic bond. Second type of chemical bond is covalent bond. Covalent bond is formed by two non-metals, two or more than two, but non-metals will combine together and then they will form covalent bond. So non-metals plus non-metals will form covalent bond. Third type is coordinate covalent bond. Coordinate covalent bond is also formed by non-metals and non-metals. Coordinate and covalent bond, they are almost similar, but they have very little difference. That inshallah you will learn in the next grade. Fourth type of bond is metallic bond. Metallic bond is formed between metals. Metals plus metal will form metallic bond. Although we have four important types of chemical bonds, but in your book or in this chapter we will discuss only two types. The two types, ionic bond and covalent bond. Ionic bond is between metal and non-metals, while covalent bond is between two non-metals. First type of bond is ionic bond. What is ionic bond? Ionic bonds are formed between two atoms when one atom loses electron to form cation and the other atom gains electron to form anion. Now we have two types of ions, cations and anion. And you know that the oppositively charged ions always attract each other. So these oppositively charged ions attract each other with a force. That force is called ionic bond. That attractive force is called ionic bond. Also called electrostatic forces of attraction. Ionic bond is also called electrostatic forces of attraction. Compounds that contain ionic bonds are called ionic compounds. Those compounds which contain ionic bond, they are called ionic compounds. Keep this in your mind that the total positive charges of the cations are equal to the total negative charges of the anion. Suppose if you have sodium ion and chloride ion, so sodium is +1 and chloride ion is -1. Charges are same. Positive charges and negative charges will always be same. Why the positive and negative charges will always be same? Because the ionic compound as a whole are neutral, because the total charge, net charge on ionic compound is 0, but the charge on individual ion is +1 and -1. Ionic bond is formed due to complete transfer of electrons from one atom to another. And complete transfer of electron means one atom will completely lose electron and the other atom will completely gain electron. That electron, they will not be shared by two atoms, so they are completely loses and completely gained by another atom. So that type of bond is called ionic bond. Metals combine with non-metals and form ionic bond. Then we have example 4.2. In order to explain the ionic bond formation, it is important to learn how anions and cations are formed, or how an atom loses electron to form cation and an atom gain electron to form anion. how anion and cations formation takes place. We will represent the anion and cation formation by a special type of structures called electron dot and cross structures. They are also called Lewis structures. Electron dot and cross structure or Lewis structure will help us to understand the formation of anions and cations. So let us go towards the first one. That is, first we will discuss the formation of cation, then we will discuss the formation of anion, and after that, inshallah, we will discuss how these oppositively charged ions then attract each other and will form the ionic bond. As I told you, for the ionic bond formation, we need cations and anions. But first of all, we must know that how these cations and anions are formed. So now in example 4.2, we will discuss how cations are formed. First of all, we will learn cation formation. After that, then we will learn the anion formation. So describe the formation of sodium cation, monocation because it has one charge, and magnesium divalent cation because it has plus two charge. Monovalent cation, valency is plus one. Divalent cation, valency is plus two. Problem solving strategy is sodium belongs to group 1A of the periodic table. It has only one electron in the outermost shell. So sodium atom loses its one electron because one electron is in the outermost shell. It needs seven more electrons to complete the outermost shell, which is not possible. So what will happen? The sodium loses that one electron and then it will have eight electrons in the outermost shell. So sodium, as it has 8 electrons in the outermost shell, it follows the octet rule. Sodium atom loses its valence electron and is left with an octet. It means the shell which is left, it has 8 electrons. Represent this by drawing the complete electronic configuration or using electron dot structure. There are two ways to express the formation of cation. The first one is, you can see here, how the formation of cation takes place. So formation of cation, solution of this example is sodium atomic number is 11. So it has configuration 1s2, 2s2, 2p6, 3s1. You can see that this is the 3, is the third is the outermost shell and it is only one electron. It needs seven more electrons to complete the third shell, which is not possible. So the easiest way is that the sodium will loses this one electron, and this shell we will not mention here. We will only mention 1s2, 2s2, 2p6. No electron, we no need to mention that uh, orbital or that subshell. So, and one electron is removed. So sodium atom is converted into sodium ion after when sodium loses one electron. You can see in this case sodium has atomic number 11. It has two electrons in the first shell, 8 electron in the second shell, and only one electron in the third shell. So sodium, after losing that one electron, only two shells will left. Then first shell will have the same two electron, and the second same 8 electron. But as it loses the outermost shell, so we will write the bracket or parenthesis with positive sign. This one positive sign means it loses one electron. Then magnesium, second part of this example is magnesium belongs to group number 2A in the periodic table. It has two electrons in the outermost shell. So same like magnesium has two electrons in the outermost shell. In order to complete the outermost shell, magnesium needs six more electrons. So those gaining of or achieving of six electrons is not possible. That is very like it needs a large amount of energy. So we can say that magnesium will lose its two electrons and then will get stability. You can see here magnesium has atomic number 12. It has two electrons in the first shell, 8 electrons in the third shell, uh, 8 electrons in the second shell, and 2 electrons in the third shell. So it will loses those 2 electrons, and then in turn will not draw in ionized form will not draw the third shell, which before or initially has 2 electrons, and now magnesium loses those 2 electrons and will form magnesium cation, divalent cation. 1s2, 2s2, 2p6, 3s2, 2 electrons were present in the s subshell, and after losing those 2 electrons, loss of electron we will mention at the right side and gain of electron we will mention at the left side. When we will discuss the anion, then we will write the gain of electron at the left side and or at the reactant side and loss of electrons at the product side. Self-assessment exercise 4.2. Describe the formation of cations for the following metal atoms. Lithium, atomic number of lithium is 3. Formation of lithium ion, first of all, we will write its configuration. Configuration of lithium is 1s2, 2s1. It has one electron in the outermost shell. In order to complete it, it needs one more electron, but as lithium is a metal, so metal always loses electron. They have low ionization energy. So lithium will loses one electron, and then the inner shell will be 1s2, which is completely filled. So you can see one electron will lose, and then there is no need to mention that one electron in this ion form. B part of this self-assessment exercise is aluminium. Atomic number is 13, and we have to explain the formation of aluminium trivalent cation. Trivalent means valency of aluminium is 3. Configuration is 1s2, 2s2, 2p6, 3s2, and 3p1. 6, 7, 2 to 4, 4 plus 6, 10, 11, 12, and 13. 13. P has one electron in its, or you can, if we count both of these two plus one, 3. So we can say that aluminium has 3 electrons in the outermost shell. So it will loses those 3 electrons, and then in turn the inner shell will completely fill. That is 1s2, 2s2, 2p6. And the electron dot and cross structure we can draw. You can see here there are 2 electrons in the first shell, 8 in the second, and 3 electrons in the third shell. So it will donate 3 electrons, or will loses 3 electrons, and then will convert it into the aluminium ion form, where it has no electron in the outermost shell. 2 electrons in the first shell, 8 were in the second, and 3 were in the third. But now 2 electrons in the first and 8 in the second. There is no third shell because third shell is now empty after losing 3 electrons, and then aluminum will get positive 3 charge. Positive 3 means it loses 3 electrons. Question number 2 of the same self-assessment exercise represent the formation of cations by electron dot and cross structure. The first example is for potassium. Atomic number of potassium is 19, and its electron configuration is, you can see, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. So as it has one electron in the outermost shell, so it will loses one electron, and then the configuration will be 1s2, 2s2, 2p6. Electron dot and cross structure of potassium. You can see potassium has 2 electrons in the first shell, 8 electrons in the second shell, then 8 electrons in the third shell, and 1 electron in the fourth shell. So potassium will loses that 1 electron and will form potassium positive ion. B part is for calcium. Formation of calcium divalent cation. So atomic number of calcium is 20. Configuration is here. It has 2 electrons in the outermost shell. So it will loses those 2 electrons, and then will have 8 electrons in the outermost shell. Calcium has 2 electrons in the outermost shell, but after losing those 2 electrons, it will get charge positive 2, and you can see the calcium ion is now 2, 8, 8. It has 8 electrons in the outermost shell, and in this case, it has 2 electrons, which it will loses and will convert it into the calcium divalent cation form. Example 4.3, describe the formation of anions for the following non-metal. Now we are going to discuss anion. The previous example and self-assessment exercise were for the cation formation, and now we are going to start the formation of anion. An atom form anion after gaining electrons. So oxygen atomic number 8. You know that first of all, you must know how to solve the problem. First of all, write the electronic configuration of all the elements, and then draw their electron dot structure. Find the number of electrons needed to complete their outermost shell. Represent those electrons which they will add. So oxide ion oxygen belong to group 6A of the periodic table. It has 6 electrons in the outermost shell, and it needs 2 more electrons to complete their octet. So you can see here, I told you that the gain of electron we will mention at the left side with the reactant, and the loss of electron we will mention with the product side. So after gaining 2 electron in P4 is converted into P6. Now the outermost electron configuration of oxygen will completely fill after gaining 2 electrons. Electron cross and dot structure of oxygen is it has 1, 2, 3, 4, 5, 6 and 6 electrons in the outermost shell. So 2, 2, 4, 5, 6 and we get this. This is one is mistakenly okay. This is by mistake mentioned 7. These are 6, 2, 2, 4 and 2, 6, not this electron. So it has a deficiency of 2 electrons to have 8 electrons. So oxygen will gain 2 electrons and then in turn will have 10 electrons in the outermost shell. Formation of fluoride and fluorine belongs to group 7A of the periodic table and it has 7 electrons in its outermost shell. It needs 1 electron to achieve noble gas electronic configuration. So fluorine will gain 1 electron and then will have completely filled outermost shell. You can see here fluorine has 2 electrons in the first shell and 8 electrons in the second shell. But after losing, after gaining 1 electron because it is fluorine and fluorine is no halogen and halogen are non-metal, they always gain electron. So it has 7 electron and only need 1 more electron. So after gaining that 1 electron, it will convert it into the fluoride ion. And electronic configuration will be from 2 to 2 and 7 converted into 2, 8. Self-assessment exercise 4.3 describe the formation of anions for the following non-metal atoms. First one is for sulfur. Sulfur atomic number is 16. Formation of sulfur anion. Sulfur belongs to group 6A of the periodic table and it has 6 electrons in its valence shell. It needs 2 electrons to achieve noble gas electronic configuration. Same like oxygen, sulfur also need 2 electrons to complete the outermost shell. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So 4 plus 2, 6 electrons are present in the outermost shell. It will gain 2 more electrons and then in turn will have 6 electrons in the outermost subshell. Electron dot and cross structure of sulfur. Sulfur has 2 electrons in the first shell, 8 electrons in the second shell, and 2, 2, 4, 5, and 6, 6 electrons in the third shell. It will gain 2 electrons, and then we'll have 2, 8, 8. All the shells are completely filled, and it will get -2 charge, which is called the divalent anion formation. Chlorine, atomic number 17. Atomic number of chlorine is 17. It belongs to group 7A of the periodic table. Same like fluorine, it has 7 electrons in the outermost shell and it needs only 1 electron to have complete outermost shell or having configuration same like the noble gases. So you can see it has 4, 5, 6, 6, 7. This is 5. Okay, this is not 4. 5 plus 2, 7 electron in the outermost shell and after gaining 1 electron it becomes 6. From 5, after gaining 1 electron, configuration becomes 6. 6 plus 2 total then 8 electrons. Electron dot and cross structure of fluorine, you can see 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons are present in the third shell. After gaining 1 electron, it has now 8 electrons in the outermost shell, and the valency of fluorine atom in this case will be completely satisfied. So dear students, this was all about the chapter number 4, how cation formation will takes place, how anion formation will takes place, and this was about their formation and their electron dot and cross structures, and also we discussed some of the anion formation as well. Inshallah, in the next lecture, we will discuss the remaining anion formation and then how ionic bond will formation will takes place between these oppositively charged ions like anions and cations. So, inshallah, till next lecture, take care. Allah.